Welcome to the lesson, States of Matter. In this lesson, you will learn how the movement of particles relates to the properties of gases, liquids, and solids. The vocabulary words for this lesson are solid, liquid, and gas. You can click each word to find out more about it. In which object do particles move most freely? Click your answer. Well done! Particles move most freely in the gas inside the balloon. Look at the other objects shown here. How do you think particles move in each of them? Matter is anything that has mass and takes up space. Even some things that you cannot see, like gases, are made of matter. All matter is made of particles, and all particles are in motion. The three common states of matter are solid, liquid, and gas. Click the photos to learn more about each state of matter. A solid has a definite shape and a definite volume. Particles in a solid vibrate in place, but they do not move past each other. This property gives a solid a definite shape. Solids have a definite volume because they can't be compressed or expanded. Liquids have a definite volume but no definite shape. Particles in a liquid slide past each other, so a liquid flows and takes the shape of any container that it is in. Liquids have a definite volume because they can't be compressed or expanded. Gases do not have a definite shape or a definite volume. Particles in a gas move quickly and are far apart from each other. A gas takes the shape of its container because its particles move apart to occupy any space that they are in. Gases do not have a definite volume because there is so much space between the particles, and it is easily compressed or expanded. Have you ever seen what happens to water when the air temperature gets very cold or very warm? Matter can change state at certain temperatures. Click the picture of the ice cube to see how water changes state as temperature changes. Liquid water can become solid when the air temperature drops to 0 degrees Celsius or below. As the temperature drops, energy leaves the liquid water and the water's particles slow down. When the water reaches 0 degrees Celsius, it starts to freeze into a solid. Solid water can take the form of ice or snow. If energy from the sun or another source is added to ice, this can cause the temperature of the ice to rise to 0 degrees Celsius. As the particles in the ice gain energy, the ice begins to melt into a liquid. Adding energy to liquid water can cause water particles on the surface of liquid water to move quickly and escape into the air. When liquid water evaporates, it becomes water vapor, which is a gas. Water vapor is invisible in the atmosphere. When particles of water vapor in the atmosphere cool, they slow down and the water vapor condenses into droplets of liquid water that form clouds. The energy in the particles of this frozen treat changes as the treat sits outside the freezer. Click to see how a particle's energy changes as matter changes state. Particles in the solid treat stay in place because they have very little energy. These particles vibrate in place but cannot move apart from each other. As particles in the treat absorb energy, they start to move more and slide past each other. This causes the treat to melt into a liquid. As the graph shows, liquid particles have more energy than solid particles. Finally, some of the particles in the melted treat have gained so much energy that they have become a gas. Some of the treat has evaporated. As the graph shows, gas particles have more energy than liquid particles. How can water exist in all three states at the same time? At some low air temperatures, ice or snow can be found next to the moving water of a stream or the deep liquid water of a lake. At the same time, water vapor is in the air. Click each labeled area to learn how different energies in water particles allow water to coexist as a solid, liquid, and gas. Energy from the sun can cause water particles to move quickly enough to become a gas, even on days when air temperatures are low. When ice forms, energy leaves water particles and the particles slow down. These particles organize into a fixed pattern and vibrate in place. In a shady area, energy from the sun might not reach the ice. Similarly, particles buried below the snow's surface would also be insulated from the sun's energy. Ice cannot melt until its particles receive enough energy to break the attractions between them, and they can start to slide past each other. How can liquid water not freeze when air temperatures are low? There are several ways. Energy from the sun can keep particles moving. The movement of flowing water can also keep particles from arranging into a fixed pattern. Liquid water deep in a lake can retain enough energy to flow when ice covers the top of the lake and insulates it. You learned earlier that ice melts at 0 degrees Celsius. But what is the temperature of ice while it melts? Watch the video to see what happens to temperature as ice is heated. Ice that is melting stays at 0 degrees Celsius while it melts. Its temperature increases only after all the ice has changed to liquid water. The energy that is added during the change of state is used to break the attractions between water particles. The same thing happens at 100 degrees Celsius when water boils and changes from a liquid to a gas. Boiling water stays at 100 degrees Celsius until it has all changed to water vapor. In any type of matter, temperature does not increase or decrease during a change in state. Drag each state of matter to the box containing properties of its particles. You got it! Particles move most freely in gases and least freely in solids. What are the differences between a liquid and a gas? Type your answer in the box. When you are finished, click OK. Particles in a gas have more energy than particles in a liquid, so gas particles move quickly and spread out into space. Liquid particles slide past each other. You've learned a lot about states of matter. Before we finish, let's take a quick look at the main points you covered. A substance's state of matter depends on the energy of its particles. The energy of the particles of a substance increases from solid to liquid to gas. Particles in a solid vibrate in place. Particles in a liquid slide past each other. And particles in a gas move freely. Now that you've finished this lesson, if you wish, you can go back and review any part of the lesson again.